In this video, I'm going to demonstrate how to use mactime and sleuthkit to create a behavioral timeline for an image file. And we're working with a DD that I created, and I copied some files to it. I set different dates on the different files and manipulated the files so that we can get a nice little example here. So if you want to find, first of all, the best way to install sleuthkit is just like this, and I believe I demonstrated this in a previous video. It's a sudo aptitude install sleuthkit, and mactime is a part of sleuthkit, so everything that needs to be installed does get installed. But if you want to know more about sleuthkit, you can go to right here, sleuthkit.org, and it's got a nice little wiki that explains everything to you and all the different parts of it. And essentially it's just a lot of command line utilities. There's also a front end to it, and we're not going to use that here because it's kind of clunky, but it works, and it's better than paying $3,000 for one of the commercial tools if you don't have the money. But this is the autopsy graphical interface, so you can do that on your own. You all are smart and can figure that out yourself. Go here to the command line utilities, and it should explain what every tool does. And this is something that we'll get into in the advanced class. But it's not as easy as using one of the commercial tools, but it's a lot easier than doing things by hand. So it just depends on how much money you have and how much time you have on your hands. But it requires some learning to understand what the command line tools do. Autopsy makes it a little simpler, and but it's still not as easy as using something like Encase or the Forensics Toolkit. And we'll use the Forensics Toolkit a little later in the course, so that you see how it's done automatically. That is, not manually like we've been doing things. So here we've got mactimes 4. I had to do this several times with different file systems just to see how they behave differently, and this one turned out nice. So we're going to use this. So if you want to know any more about mactime, you can go to the man page for this. This is installed automatically. And we're not going to be using all the options. What we do need is something called a body file, and that's created by the FLS command. So it lists the files and directory names in a disk image. So for example, if you type FLS -R on, what was I call this, mactimes4.dd, it lists all very limited information on, for example, the file name, the INO number, whether a file was deleted or not. And so that's kind of hard to read. So essentially what FLS does is it sets up you for the next command. And I'll show you how to do that. So let's just go back to man FLS again. So we'll use the -R. We'll see what that is in a second. The -M, which is the mount point, and we'll need to set that. So where do we want to start reading within the DD? Notice we can display deleted entries only with the -D. We can specify the file type if it isn't able to figure that out, and it should be able to figure it out. I've never seen where it wasn't. Notice the -R is recursively display directories. And it gets a lot more complicated, but typically we'll just use the -M and the -R. And so once again, that's one of the command lines in command line utilities in sleuthkit. So we're going to run FLS. We want a recursive directory listing, just in case there are any directories on there with files in them. We need to set the mount point, which is just the root mount point, whatever that is. Let's run. I'll show you what this is, mactimes4.dd. It's an ext2 file system, so it's a Linux file system. So, okay, so we'll run fls with the -r for recursive, -m for the mount points. We just want whatever the root is, and if that was a VFAT, that would be whatever that root is, would be C probably. And then we have to list the mactimes4.dd, and we're going to write this out to a file called body4.txt. We hit enter. Now let's go and look at body4.txt. And this is going to be in a mactime format, so it's not supposed to be human readable, but I can read some of this. But you can see some of the things like this list of directories and the files, their inode numbers. And remember again, inodes is how the operating system and file system reference a file, not by their name, but their inode number. Because their name may not be distinct, but inode numbers always are. And we have the owners and group ID, user ID and group ID here, 0 and 0. And then we have offsets. These are mactimes. And mactimes are always offsets from a specific date for any operating system. And for the Unix, that would be the Unix epoch, which is January 1st, 1970. For DOS, it would be January 1st, 1980. But you can look that up. So you see this is a lot simpler example, or this is a simple example. So now we can run mactime, and we give it the body4.txt, and then we want to say a start date, and so we'll just give it the Unix epoch, because you can go in and start from any date you want, but we'll just start with everything. And then we want to out that to mactimes4.txt. And then we look at mactimes4.txt. Here we go. So just a few simple files. So it starts out on Wednesday. What I did was I went in and I kept resetting my date so you could see the differences in, just so there were some differences in the dates and times in here. So some of this looks funky. For example, here, the bottom, Wednesday, December 12th, 2012. Oh my gosh, we're on the Mayan calendar, right? Let's go back up to the top, Wednesday, July 7th, 2004, at 19 seconds after midnight. You'll see this i.jpg was modified and accessed. So when was the file copied here? Remember the changed date. When anything is just first copied here, let me step back for a second. If we, as we saw in the previous video on mactimes, if you just copy a file over here, the modified access and change date are all going to be the same. So notice deleted.txt. Modified, accessed, and last changed on July 7th, 2004. The same thing with this RATIUG, which is guitar backwards. So they were modified, accessed, and last changed on that date. Notice that i.jpg, which is the first line, it was modified and accessed on that same date, July 7th, 2004. So where's the C? Well, we can go down and find out that, see the change right here? Then on January 1st, 2010 at 8:22, this changed. So something about the metadata changed. And you might be able to guess because you notice that a lot of these files are owned by root. Notice the UID of 0 and the group ID of 0. This is the only one that has a user ID and a group ID of 1000. So that's essentially what I did, was I changed the ownership of the file to me, which meant that the change time was updated because that's part of the metadata. Okay, so keep moving down. Tuesday, July 10th, 2012 at about 11 o'clock. Modified, access, and changed for the directory. Notice here, lost and found. So that was created on that date. So it's a little bit easier to interpret something that has a modified access and change date that are the same, because we can kind of interpret that it was created on that date. Body1.txt was modified about the same time, notice that body 1 modified and changed. Body 1.text, notice the A is missing. Let's go down and find body text down here. And we see it was accessed December 12th of 2012. So how would we interpret that? Well, we might interpret this as if it was modified and changed on July 10th, 2012, and it was accessed, that means that something accessed the contents of the file at a later date. What's that, 3 or 4 months? So what I did was I catted the file. Well, to cat a file, you have to access the contents. Thus, the access time changed. But notice the modified and change time didn't change. So let's move on down. Let me see. Body 3.text is July 10th, 2012. Notice this says body.text and has the ampersand after it, and it says it was deleted. Well, what's this body3.text.ampersand? Well, you kind of need to know a little about the applications that create these files, and what this was is this was a backup file because I opened this file in Vim, V-I-M, which is a text editor that you find on all Unix systems. And so this body3.text, notice that it was last modified on that date, July 10th. Notice it said it was deleted here. If we move on down, it was last accessed on July 12th, body3.text. And it was last changed, body3.text. And how would this occur? Body3.text. Well, I opened the file. So essentially what happened was I opened this body3.text and I added some stuff to it. Well, at that time, a temporary file was opened, and that's what this body3.text ampersand is. And then when I saved the file, notice that it went from 0 bytes up to 8. So I added 8 characters to the file. When I saved it, the modified access and change times were updated. And notice also that there's a swap file here, which is really interesting that it doesn't have an access time for this dot. Oh, yes, it does. Here's the access time for a swap file as well. Last accessed here and last modified and changed here. And let me see, let's go to see the last one here. Yiddish was a file. It was last accessed on Tuesday, July 10th at 2012. If we go down here, there should be, if there's only 2 occurrences of it, then if this was accessed up here, then here it's got to have the modified and change times. And when you delete a file, if you see what happens is, in this case for the swap file, in this case for Yiddish, that the modified and change times were updated to December 12th, 2012. Also, something I didn't point out the other day, and we'll take a look at something else. But anyway, remember that these are the timestamps over here, and everything that's under that will use the same timestamp. So, for example, Wednesday, July 7th, 2004, the first timestamp, i.jpg, deleted.txt, and guitarbackwards.pdf are using that timestamp. And then in the second to last column are the inode numbers.